Hi there, I am Juvannie Alquizar, and in this video we are going to talk about semaphores. Semaphores are basically useful for sharing resources throughout process or threads. I have already a C program right here for semaphores. To demonstrate it, we are going to compile it first using the terminal. So to open up the terminal, you just have to press Ctrl Alt T, and then you have to navigate to the desktop where our C file is located and compile the C or compile the semaphore program. So to compile, we have just need to type in GCC. By the way, GCC is already installed when you are using the I guess the later part version of the Linux or the Ubuntu. To check if it is actually installed, then we have just to type in GCC and then dash dash version. So as you can see right here, we are at version 9.4.7. To compile the semaphores, let's see, we just have to type in GCC and dash O, and we have to input the name of our output file, which we will call semaphores, the space, the file that you want to compile, at image, then dash lp thread dash lrp, hit enter. I know, I've typed in dash h right here, so we have to do it again. GCC dash o, so setting semaphores, let's see, dash lp thread dash lrp, and hit enter. As you can see, the semaphores output is written right here. To open up this output, you just need to type in dot slash then semaphores. As you can see, it output entered, and for a little while, just exiting output is created, and another thread is created right here, the thread number 2, which again access the entered print, and just basically the same what on the first half of the program. To have knowledge on what's going on, I think we need to open up the source code of this program. Right here, we are using a semaphores in this program. Obviously, to do that, we need to include in the library semaphore.h, and might as well the pthread.h for creating the threads. And then we need to declare a variable for our semaphores. We can do that by typing the data type sem_t and the variable name, which we call in this case mutex. If we go to the main function, we need to initialize first the semaphores. To do that, you can use the sem_init or initialize function, and we need to pass in the reference, of our semaphore, which in this case mutex. And for the second parameter, it will take a 0 value, which means that the semaphores will be shared by the threads. So if we are going to use a non-zero value, then we are basically telling the program that the semaphores will be shared by processes. And for the third parameter, it is basically the initial value of our semaphores, which in this case we use 1. And next, we are going to declare a thread variables. So to do that, we are going to declare a pthread_t, which is a data type for a thread, and then the names. Then we are going to create that thread. Then we are going to create a thread by using the pthread_create function, and we are going to pass the reference of the thread that we want to create. And then it will call on the thread function, which is right here, and it will take a void pointer argument. So in this thread, in this process, we are going to dissect it one by one. In this part, the actual in this part or the in the wait part, the thread is actually testing whether there are any thread that are that is present or accessing currently the shared resources. So by using the sem underscore wait function, the thread that thread is taking the value or passing the value of the mutex to test it whether there are any there are any threads that is currently using the resources. As you can see here, we are initializing the semaphores to 1. So basically, there are since it is the first thread that you have created, the value of our semaphores right here is actually 1. Now, in this function, the same underscore wait function, if there are or if the mutex value is equal to 0, meaning there is a thread that is using currently the shared resources. In that case, the thread or the thread waiting right here or the thread testing right here cannot proceed as long as the existing thread is not finished on executing its task. However, if the value of your text here is equal to 1, which is in our case is equal to 1, then the the thread can proceed to its critical section, which is the sleep for 4 seconds, meaning the thread will actually stop for 4 seconds. As you might have seen earlier, that when this function printf entered lags a bit before outputting the just exiting printf function, because there is a sleep function here that enables the thread to stop working for 4 seconds. That's why we have a bit of lag earlier. Next, after the thread executes the critical section, it will go to the post or the same post function. Before that, we are printing the exiting just exiting string to know that we are actually in this part of the program. So this same post function will actually tells the program that the thread has finished. How does it tell that the thread is finished? Going back to the wait function, after executing or after the thread passes or after the thread check that there are no another thread that is using the shared resources, it will actually decrement the value of the semaphore, meaning if you have 1 here, it will become 0, disabling the other thread trying to get the resource right here to proceed, meaning they cannot proceed unless this thread actually finishes its task. So when it finishes its task, it will go to the post function right here, and it will actually increment the value of the semaphores, meaning that the current value right of the semaphores right here is 0. Then the after the thread finishes, the value of the semaphores will actually go back to 1. Another thread can actually go or can actually access the shared resources. So if we go back right here, after creating this thread, the thread will actually sleep for 2 seconds more, and we are going to create the thread number 2. So it basically works the same as thread number 1. However, it only executes after the thread number 1. And that's for this pthread join function. Well, this is actually quite useful because it will enable the thread to finish before continuing. So if we are so meaning if the thread right here finishes, then after that, well, only the next function or the next set of statements will run. After creating this, after executing this whole bunch of codes, the semaphores will be destroyed or will be deleted and the program will end. That would be all. Thank you for watching.